In this section, we're going to talk about ionic bonding. Before we do that, let's just have a brief introduction to the three basic types of chemical bonds. The first is ionic bonding. Ionic bonds form when there is an electrostatic attraction between ions. That means an attraction between a positive ion and a negative ion to form that bond. Covalent bonds form when electrons are shared. So it's a result of the sharing of electrons between atoms. And metallic bonds are where each metal atom bonds to other metal atoms around it within a sea of electrons that can freely move throughout the metal. All right, so as a reminder, an atom's electronegativity is how strongly that atom attracts electrons from neighboring atoms. So atoms with a high electronegativity will be able to attract electrons away from atoms with a much lower negativity. That's how we form ions. So once a positive and a negative ion are formed from that high electronegativity atom attracting and removing electrons from those lower electronegativity atoms, they will be attracted to each other via the electrostatic force. And we know that that's just the attraction between opposite charges, a positive ion and a negative ion, attracting each other to form that ionic bond. Let's look at this ionic bonding in a visual way. In the top diagram, we have two neutral atoms. On the left, this outer shell has one valence electron and has very low electronegativity. On the right, in this outer shell, we have 7 valence electrons, and we would expect a very high electronegativity there, again, because gaining that one remaining electron will get the atom to 8 on the right, whereas losing this one valence electron will get the atom back to a full stable outer shell. So what happens is the atom with the higher electronegativity attracts and removes this electron from the atom with the lower electronegativity, and we get two ions formed. The one on the left will become the one on the right will become negatively charged, and the one on the left will become positively charged. So we have two oppositely charged ions formed. When those atoms become oppositely charged ions, the electrostatic force of attraction brings them together. So this positive charge is attracted to this negative charge. We're demonstrating that by the arrows showing them attracted to one another, and that force of attraction is the ionic bond. That's what holds the atoms together. Compounds that are composed of cations and anions are called ionic compounds. Though they are composed of ions, ionic compounds overall are electrically neutral. So that means the number of positive ions, or the overall charge of the positive ions, has to be balanced by the overall charge of the negative ions to get an overall electrically neutral compound. And again, just to reiterate, the electrostatic forces that hold ions together, that positive and negative attractive force, is the ionic bond. That's what we call the ionic bond. We demonstrated a few slides back visually how an atom with high electronegativity attracts and removes an electron or electrons from an atom of lower electronegativity. In order for that to happen, there needs to be a big difference in the electronegativity values. So remember when we were talking about electronegativity earlier in this presentation, we had fluorine with a really high electronegativity, 4.0, and on the left-hand side, some of those other metals are much smaller, like below 1, and the difference there is very large. You need a big difference in electronegativity for one atom to be able to take another atom's electrons. So one electronegativity must be high. That atom really needs to want to gain electrons, and the other must be low. That atom is really readily willing and able to release its electrons. This large electronegativity difference only occurs between metals and nonmetals. So when we're looking at a list of compounds, we can easily distinguish ionic compounds because we're looking for compounds that include both metal and nonmetal.